All right. So welcome everyone to SO Connected and to our session today. This session is about Labster in the classroom, how to acquire theoretical knowledge through a practical way. Before we jump into our topic, I do want to quickly review some housekeeping items. First, I encourage you to write your questions in the Q&A, which is located in the bottom toolbar, and we'll answer your questions at the end of the session. And second, this session is going to be recorded like all the other ones at the event. So please check your email inbox for the recordings over the next week. And lastly, if you have any questions following the sessions, please email info@labster.com. Without further ado, I'm delighted to welcome Andrés Garzon, Professor of Genetics at the Universidad Pablo de Olavide in Spain. Welcome, Andrés.
Thank you, Emily. Nice to be there. Nice to meet all of you. And good morning there in the States. Good afternoon here in Spain.
Great. So, Andrés, we know that professors are always looking for new strategies, methods to help their students learn. So my first question to you would be, to what extent Labster's learning strategy has helped your students retain knowledge better and faster?
Okay, first question and very difficult answer. It's going to take a while. So no, I'll try to be brief. In principle, let me start with a little bit of background because you know, the context, the academical context is always very important to understand all these tools and the resources that we apply. So I teach a master's degree and so everything I'm going to talk, or most of the things are about this master degree. Is health biotechnology master, or medical biotechnology master degree. So I teach graduate students, and this master is spans over 6 quarters. So it's 1 year and a half basically of teaching, and the first quarter is online. Okay, so we have a starting quarter is a leveling period. We have students from different academic backgrounds. So so we need this first part of the master degree to level students, like a propedeutic module, right? So you know, when you get these surveys of satisfaction, of student satisfaction, they were always saying that this first quarter was very hard, was very boring. They were alone at home. They were just reading papers and writing reports and these kind of things. So 5 years ago, in 2017, we just decided to change everything here and to move from a transmissive model of teaching, of learning, to a more constructive, more hands-on activities, more practical, even for theoretical learning, which is the case, right? But so Labster was a very important part of this strategy. We started using your labs, your simulations, just in a context in which we just moved from the typical teaching from the professor, just transmitting knowledge or information, to a more global, let's say, hands-on methodology. So the students and the professors made some kind of teaching community or learning community, right? Where problems were on the table and the students had to solve them, and they had plenty of tools to that. So Labster was one of the tools. Then we used very intensive use of forums, asynchronous communication strategies, so we could build knowledge from this basis. So from that point on, the satisfaction of the student just changed completely. They really appreciated that they were learning. They were learning how to do things. Not only they were acquiring knowledge or just information, but they were learning how to do things. And that was very important to prepare them just to in-campus learning, right? So they, starting the second quarter, they just came on campus and they started the physical face-to-face learning strategies, and also the wet lab practical courses, which were the, let's say, like the second part of the master degree. I don't know if I've been able to put in context the situation.
I see. So this learning by doing approach is what helps them acquire the knowledge.
Basically all over the year, because we have all these lab physical labs where they were, of course, learning by doing, but this very first part, the leveling, the basic knowledge, that was hard for them. And so they just changed their perception of how they were learning very strongly, right?
Oh, okay, understood. So you've been using Labster as a pre-lab exercise mostly, right?
Excuse me?
You've been using Labster as a pre-lab exercise.
Right. So we have these two ways to use Labster. Is you can use it like a grading tool or like a learning tool. So definitely for us it was a learning tool. So we didn't use Labster for grading. So we have another kind of grading techniques. So we didn't use for grading, but we use it for learning. So as I told you, because one of our concerns, we have talked to that intensively, is the academic level of the simulation. The simulation looks more focused to high school and undergraduate students more than, let's say, graduate students, that they were supposed to have already a higher level or more practical skills. And in that context, we have understood that the level is good for this very first quarter, in which we have to level the academic backgrounds of the students. So this master is very intense in genetics, and so you have people from physics, from chemists, from pharmacists, and they have to acquire these basic genetic competences. Labster has been great for that in our hands.
So since you mentioned you're teaching master's degree in health biotechnology, what are the specific challenges that you see that master's students are facing compared to bachelor's, and how do you see Labster helping them face those specific challenges?
Right. It may be different in different countries or in different systems, right? But our bachelor students, they come to our universities more, uniformly prepared, right? So the knowledge is more predictable, it's more uniform, and it's easier to plan a learning strategy for them. In masters, the students are more heterogeneous, and so even if you assume that the academic level of the simulations may be undergraduate levels, it's good for them, because you can have people from pharmacy to make labs for genetics, and that doesn't mind if the lab is graded for undergrads, right? So it's going to help them to level and to acquire the basic genetics competences that they will need throughout the whole master. So great. I mean, practicing is never without use, or it's never useless, right? So it's always or even our biology students that are well prepared in genetics, they appreciate this tool, which is not very common in Spanish universities. In fact, we were the first ones to adopt it, the first public university, as I believe. So students coming from other universities really appreciate the competences that they can acquire from home using virtual labs.
Right, and as you say, it really helps reducing the knowledge gap between students once they enter the masters.
Right, that's the main point, right? So so to level the knowledge gaps and to prepare them to understand the techniques that we're going to go through the whole master. Yeah.
Very clear. Thanks, Andres. Is there any last insight that you would like to add to our audience on your use of Labster?
Well, you know, now, in fact, the two main points is that Labster has a very nice learning strategy. So that's what I like from Labster. Labster has very impressive simulations and 3D graphics and all this stuff. But the thing that made us acquire or adopt Labster was the learning strategy. So that situation in which the student is not alone with the simulation, but is all the time is guided by questions, and so they can just, if they can answer a question, they can just go and read some background and then try again to do the simulations, and that path, that you know, that working in this direction is what they help them to learn. So for me, more important that the grades that the platform gives, that at the end you have a percentage of answered questions and so on. For me, the most important information that I get from about my students from the platform is the time that the student takes fulfilling the simulation, right? So that's telling me how difficult it was for him or for her, and how helpful the simulation has been. So being a learning tool, not a grading tool, we let them make the simulation different times, several times if they want, and the way that they shorten that time of performing is a very nice tool, a very important way to know how the students are acquiring the competences along the practices. So that's fine. On the other hand, we have plenty of wet lab experiences. So in my point of view, this simulation is not, at least in our hands or in our strategy, is not like more for substituting the wet lab, but to preparing the students to perform in the once they start their projects in the wet lab.
Very clear. Thanks a lot, Andres, for sharing your experience. Maybe it has inspired other teachers, admins to, and maybe you have questions on what Andres said along the discussion. So I'm gonna go through the Q&A and see if we have any questions. Not yet. It is your time.
I'll be glad to answer anything, or even you can provide them with my email if they have further questions.
That would be fantastic. Thanks so much, Andres. maybe we'll wait for another minute, and
Sure.
if not, then yes, we will provide your contact.
Mhm.
Well, seems like maybe it's gonna come later. But in any case, Andres, thank you so much for joining us today at the SO Connected, and for sharing your invaluable thoughts. I hope it has inspired others. And I also want to thank all the attendees for taking the time out of your incredible busy schedules to connect with us today. So now feel free to go to the next session. We're going to start soon. Thanks a lot.